Welcome, everybody. My name is Larry Shafter. I'm a Stormwater Program Coordinator for Thurston County and your host of this session. We have Shelly Basketfield from Seattle Public Utilities. She's going to give a presentation on street sweeping, cost-effective wash-off, and appreciated blow-off.
Thank you all for coming. I'm really surprised so many people are interested in street sweeping, and I'm really excited because I love street sweeping. But before we get started, I'd like to introduce Rex Davis. Rex, you want to stand up? Rex is our assistant program manager. He's managed collection of over 250 samples, which we're going to look at that data today. He's optimized all of our routes. We have over 40 of them, and he's been instrumental in the success of the program. So this is what we're about today. Street sweeping for water quality. It really is cost effective, and we have the data to show it. But identifying 6-DPDQ as the urban runoff mortality symptoms cause has really refocused awareness on roadways as prolific producers of potent stormwater pollutants. So if you're in the business of street sweeping, you always knew that, but not everybody really paid attention to us. And if we measure what matters, it shows that street sweeping does cost effectively reduce those roadway pollutants. But there's low confidence in sweeping effectiveness, which all of you know, that holds us back from fully implementing this low barrier technology to address roadways and protect aquatic life. So when I'm on the bus and I'm talking to people and I tell them what I do, they're like, wow, street sweeping, you're protecting the water. That's really cool. But if I talk to other stormwater professionals, all I ever hear is it creates fines. And I'm just like, oh, how can people still think that? So hopefully at the end of today, we will have changed your opinion if that's what you think about street sweeping. So we're going to do that by shifting to a source control perspective, and that will put sweeping front and center in the fight to reduce the impact of roadways on our stormwater quality. We have been looking at street sweeping as if it is a treatment BMP. And we keep analyzing stormwater concentrations, but street sweeping is a source control BMP. So we have 3 steps that we follow to look at street sweeping from a source control perspective. So number 1, we measure to produce actionable results. Number 2, we use that data to reveal meaningful insights. And then 3, we drive holistic stormwater program integration. So we're going to walk through each one of those today. And at the end, I'm sure you will all be positive that street sweeping delivers more environmental and community benefits at lower costs. So we'll start with number 1, produce actionable results. We'll first look at measuring what matters. Then we'll look at being practical in our approach. And then we'll look at the results. Tie the results to operations. So as we walk through these, you can see where'd my cursor go? Up on the right, top right, there's the little indicator of where we're out on the triangle, because you can kind of follow along as we go through the story. But first off, we want to change that whole perspective. Not a treatment BMP, it's a source control BMP. And we can continue to ask the same question, does street sweeping reduce stormwater concentrations? And we'll probably get the same answer. It does, depending on what study that you look at. If you look at the studies in Western Washington, Redmond, Tacoma, and Seattle, we have shown reductions in stormwater concentrations. If you look at studies that take place more in the Midwest, West, or the East Coast, it's been really difficult. There's a lot more variability, and they need huge sample sizes. So if we think about, does street sweeping reduce the source of pollutants on roadways, then our whole hypothesis changes and our approach to sampling changes. So the hypothesis is regular street sweeping controls the source of roadway pollutants, reducing both the wash off and the blow off from the roadway to the environment. So to get to where we want to go, measuring results that matter, we first need to understand the problem. If you look at the diagram here, our source pathway receptor conceptual model, our primary sources, we have vehicles, which are our worst contributors. The road surface itself is contributing pollutants. We've got trash, and we've got leaf and needle drop and grass. So that all ends up in the road where it gets stored. And then on the road, we've got processes happening. Number one is particle size reduction, just the cars going over, reducing the particles, the wind and rain erosion particles are continually getting smaller. If they're small enough, like about less than 75 microns, they're going to blow off the street. That's about 85% of the particles on the street into dust. About 15% are going to wash off in rain to stormwater. And then from the dust, the wind is the primary receptor, but we have a secondary release mechanism. And that's when the dust, we have wet and dry deposition, comes back to stormwater and or our surface water and sediment. So studies, and in the early 70s and 80s, 90s, up until the 2000s, we've been focusing on number one, trying to measure what's happening at the basin scale, really mixed results, and pretty much everybody takes those results and uses a model to predict what's happening. So over time, we have been moving up in the upstream, better results, but sample size is still a problem because there's so much variability. And then three is where we at Seattle have been measuring, is right at the road surface. What did we pick up? And you also, if you look at people who are concerned about nutrients, Minnesota, Chesapeake Bay, Florida, they're all starting to measure what they picked up with the street sweeping, because it's the whole package of nutrients, not just what ends up in the streams. So on the bottom, we're looking at increasing time to implement and investment costs, and the increasing cost per unit of pollutant removed. So the best thing we can always do is behavior change. If nobody drives their cars, then we don't have any problems. But next best is street sweeping, source control. Next is the street scale BMP, get it right off the street. And then the last thing we want to do is basin scale BMP, because it's so much water, concentrations are now diluted, and it costs a lot of money. And if you're someplace like Seattle, we really just don't have places to put those kind of treatment plants. So if we collect all this data, we need to ask what we're going to do with it. And so that will help inform the data that we want to collect. So what we want to know is, what should we do more of? We want a performance-based approach. What should we do less of? And what should we do different? So, and you can see up here on the right, we've changed to part two, be practical in approach. So we've started off with a public value chain map. So we start with the resource. We invest in a clean street partnership with our Seattle Department of Transportation. And that's one of the reasons we've collected so much data, is because we're a partnership and we share the costs. So to share the costs, anything that goes to the MS4, we pay for. Everything else SDOT pays for. So that's why we have all this data. It's not just because we're data geeks, but I am a data geek, but this is the justification for it. So once we have our resources, we are going to produce a service. So we sweep Seattle's arterial streets, mostly at night, using regenerative air sweepers, so that we produce results. We remove roadway debris, leaves, trash, and attached pollutants, reducing SSOs and flooding from leaf block pipes and inlets, so that we have an outcome. We reduce the pollutant load washing and blowing off the road, protecting environment and community health. And then for each one of these, we have metrics. So we have leading and lagging metrics. If we only measure the cost, we really don't know what we're getting for it. If we only measure our outcome, we don't know how we can do better. So if we have metrics for each one of these boxes in our chain, we can improve our results and figure out what's working and what's not. So we want to keep it simple. We dump 2 to 3 times a shift, and we have a stockpile, one in the north, one in the south. So if you're sweeping streets in the north, you dump in the north, and same for the south. So once the material's in the stockpile, then we're collecting composite samples. And you can see over here in the pile, there's a couple little holes where the composite samples were collected, about 2 to 3 feet below the surface. And depending on how much material is there when we sample, if there's a lot of material, you take more samples. Down here, you can see Rex is preparing the samples. And then we end up with 2. And one sample we sieve to less than 250 microns, analyze that for the less than 250 concentrations, and we assume that is going to represent the wash-off concentrations. The rest of it, the primary environmental sample or the whole sample, we analyze all the pollutants in that sample. And then once a week or so, we haul the material down to our vendor, and then we get our wet scale from our vendor's truck scales, and that's what we use for our, it's really our basis of everything we do. So sampling frequency from 2013 to 18, we were sampling every 2 weeks. We dropped down to quarterly, and last year, or this year actually, we started picking up our frequency because we're adding 6 ppdq to see if we're picking it up, but we do want to be able to correlate the 6 ppdq with everything else we've been picking up. And just in case you're interested, the parameters are here and the cost. The 6 ppdq, we're using Eurofins in Sacramento. It's not cheap. Hopefully in the future, the cost will come down, but it's something we think is important right now. So rather than doing a treatment BNP, analyzing for a treatment BNP, and then modeling, we're analyzing for the whole environment and then modeling what's the wash off or the stormwater piece. So if we start off with our whole environment load, and that's the measured primary environmental sample concentration times the total solids times the measured wet weight from the vendor scales. And then we calculate the TSS, which is the roadway particulate matter wash-off model. So back in the early 1980s, Pitt did a study in Bellevue of 50 samples before and after rains, and he did particle size distributions. So we take those particle size distributions and apply them to the particle size distribution in the sweepings that we collected. And that's how we figure out how much would have potentially run off the street. So that's their TSS equivalent. And then from that, we get our wash off load, which is 3, the whole environment load times the wash off load, and then times the less than 250 concentrations. And then the blow off load is really just the difference. And then pervious, and there's an error here, that should say 35% pervious. So we take the pervious area then and multiply that the blow off load and just split that into pervious and impervious. So if you look here on the map, here's our routes. In the green, it's kind of a skinny line here, is a 100-foot buffer on each of the routes. And then the yellow is a 500-foot buffer. So theoretically, the stuff is blowing off the road and landing somewhere. And for reference, in California, anything that is within 500 feet of a freeway, they regulate any sensitive uses like schools, anything to do with children or people who have health reasons. So a lot of the particles are going to settle out pretty quickly. Some of them go for quite a long ways. So we've just changed, we're now tying results to operations. So our 2013 to 2018 study period, and that's when we were collecting samples every other week. So the north and the south, the north and the south kind of splits here at the Ship Canal. There's less routes up here. You can see it's a lot more dense down here in the south. The north is more residential, about 64% contained compared to the south, which is 40%. And you'll see that as we walk through on the results. The other thing you'll notice is that we have 3 seasons for sweeping. We have a dry season, May through September, leaf season, October to December, and then the wet season is January to April. And we split the typical wet season, we split leaf out of it because things are so different during the leaf season. We pick up a lot of leaves. They're very wet. It's a lot of mess. So we do use technology to automate our operations, but we also really depend on our operators to tell us what's going on out there. And things have changed since we started. in 2010. Things are a little bit more scary for the operators right now. On the right side here, right on your side too, the green, so this is an AVL, automatic vehicle location trace. So the green is the actual sweeping and the red is that travel time. And this, oops, sorry, this is Route 17. So just the last 4 times that Route 17 was swept, you can see on the top line here, the velocity has changed quite a bit, a lot of variation. The pickup also from 483 pounds per mile to 282. So every time you sweep a route, and this is just in, things are different, things happen out there. And utilization is the time that we're actually sweeping out of the shift. So if we have a 10-hour shift and we sweep 5 hours, that's 50%. And we have a new guy who started on this route in January. And he's doing great because 50% is our target and he's hit it every single time. So we do optimize the routes. There's about 40 routes. So if you can shave off 30 minutes of travel time on every route, it really makes a difference in your costs and what you're actually producing. So this is Route 03 over here, and you can see the previous route was long and skinny. This one has a lot of turns, and typically if you have too many turns, it's going to be less efficient. When we look at the routes, optimizing them and scheduling them, one of the things we think about is the percent in the MS4. So we have a lot of routes that are downtown. Most of those are combined, and those we sweep weekly because it's Seattle and it's dirty and we don't want to have it dirty downtown. So after that, we prioritize routes in the MS4. So this is just listing routes in priority. Pink is Route 3, which you're seeing here, and then the yellow is the long route from the slide before. If we look at the utilization, you can see they're fairly close. The more travel time, the less sweeping we got. So we really want to think about how to increase more sweepings for some of the ones that have poor utilization. The velocity, how fast, some of the routes are just slow, like if there's a lot of turns, some of them, if it's on arterial, they can go pretty quick. And then the annual pickup rate. So these top 2 routes are leaf routes, and you can see they're picking up a lot. 03 is at one of the top, and 17 is down here. If you're picking up a lot, then maybe you need to sweep that route more frequently. So that was the end of step 1, measure to produce actionable results. And now we'll move on to analyze the data to reveal meaningful insights. So first we're going to talk about there's more to the story than fines. Then we'll talk about the unappreciated pollutant load reductions from blow off, and then fine tuning performance. So this is just my personal bias. It's way past time to stop throwing street sweeping under the bus. And I actually got excited with the 6 ppdq thing because I was like, finally, street sweeping is going to get recognized for the value that it provides, because we just keep throwing it out of the bus. And I'm hoping all of you guys are going to take it, not put it under the bus anymore after this talk. So street sweeping does reduce the pollutant load available to wash off. And we're looking here at the wash off as a portion of the street load with the approximate size distribution. And this is all just for illustration because I took the pit data with the runoff particle size distributions and our data with what we picked up. So I'm mishmashing them together to tell a story. So again, what's happening on the street is really dynamic. It's not static. Things are always changing. So this is just to tell the story. But if there's no sweeping and we use the pit data, about 16% of what's on the street would have washed off. About 38% of that would be greater than 250 microns, and 62% would be less than. So rain removes the fine particles. It doesn't really have enough energy to move the big particles. And if we're sweeping before the rain, the sweeper picks up more big particles and less small particles, then we'll remove about 12% of what's on the street. So that's about a 25% removal efficiency, which is what we found in our Seattle study. And you can see there's slightly more fines, but this is the less than 250. So if you broke that down, there would even be more of the really small stuff. But if we were going to sweep after the rain, so after the rain, there's less fines on the road and street sweeping is picking up more of the bigger pieces, then potentially, I mean, it could be a lot more. You could see here the proportion of fines has gone way up, but it's less material. So then again, this is just for illustration. So if we start off on the street, if we have 100% on the street, according to the PID data, about 25% of what's on the street would be less than 250 microns. So after we sweep, you see that that increases to 57%. There's more fines after we sweep. But the thing that we keep forgetting is there's like 75% that we just took off the street. It's a massive amount. And it's not clean. Even though it has larger particles, those larger particles still have pollutants attached to them. So the one thing, we did a study that was published in 2018 that measuring what's washing off the street. And what we did find that about 24% of the TSS removing or carrying about 17 of the particulate copper and 18% of the zinc. So we are getting pollutant load reductions, and that's just what's washing off the street. So what we're looking at here is concentrations in the street sweepings, and they vary just like stormwater, which since it's the big source of stormwater, we shouldn't be surprised about, by particle size, season, and location, which is indicative of the land use and the year. So we're looking at the north are blue, south is in yellow, and then you'll see the dry season, the leaf season, and the wet season, and then the whole environment load concentrations and the wash off concentrations. And you can see, you know, there's like pretty clear trends here. The whole environment concentrations are less, the wash off are higher. Dry season, wet season, dry season, a lot of variation. Yeah, and the one thing to note here that the higher concentrations in the less than 250 micron fraction. So in order of preference, PCBs are 7.7, less than 250 to greater than 250, copper is 3.4, zinc is 1.9, and phosphorus is 1.5. So it doesn't matter how much in phosphorus, if you take the load off, you're taking the load off. Whereas if it's something like PCBs, you really want to try and get those finer particles. So this, we're looking at the TSS, which we're predicting from our model. Again, the north is in blue, the golden is south, and the dry season, leaf season, wet season, and here's the median concentrations. So in the dry season, like 10 and 11, leaf season, 8.7, 11, in the wet season, 13 and 14. Down here is just the less than 63 microns. So you can see that we are picking up that fine material. And these concentrations are in the range with the literature. So Sutherland, he uses his symptom model, and he thinks what we pick up for sweeping should count between 10 and 25%. And if we look at the Windslam model, depending for the Chesapeake Bay North, I use their data, so it's not really applicable, but it's in the ballpark. And there's 16 and 11% depending on how frequent we would be sweeping. And here's, just in case you forgot how we get to this TSS, we just apply the PID data to our particle size distribution. So we've just moved into unappreciated pollutant load reductions. And if you don't remember anything else from today, what I hope you remember is this iceberg. On the top, about 10% of the particles that we remove carrying the higher pollutant concentrations, that's the water quality, that's the stormwater. But down here, we got 90% of the particles, and they still have concentrations. They're lower than the fine particles, but it's still pollutants. And if we only focus on this 10%, we're really missing out on the impact of street sweeping. So looking here, we've got 2018 metal load, pollutant load reductions. The wash off is in blue. The gray is what would have blown off the road and landed on an impervious surface, and green is what would have blown off and landed on a pervious surface. So you can see for zinc, 42 kilograms is what we would count for stormwater, but we're removing 307 kilograms from the environment. This is just looking at it in terms of the mass. What does this really mean? So in zinc, in 2018, we would have removed about 11.4 1-gallon milk jugs of pure zinc, copper about 3, chromium about 2.2, lead about 1.2, and nickel about 1.2. If you think about the lead, there shouldn't be any lead. Where's the lead coming from? But we're still taking lead out. Down on the bottom, we're looking at nutrients. In 2018, this would have been equivalent to about 1,000 bags, 1,050-pound bags. So it's not insignificant. This, we're looking, Seattle is 1/3 combined, 1/3 separated, and 1/3 partially separated. So this just looks at what we're doing in the combined system also. So by removing things also from the combined system, we're reducing loads to CSOs, and we're reducing the pollutants that are going to the treatment plant. And if you think about the treatment plant, it removes metals if they end up in the biosolids, and then we're just putting them back into our food supply. So this is a good thing. This is looking at same thing, box plots, but now we're looking at the pickup rate, the mass per mile that we sweep. And that's really what we use to figure out where we need to change, why we need to change, what's working, what's not working. So same thing again, north is in blue, south is in yellow, and then dry season, leaf season wash, wet season. And you can see it's kind of the same type of trend, but if you look here for TSS, the whole is quite a bit, the wash up is quite a bit less. Phosphorus, same thing. Fecal coliform, we pick up, well, we measure a lot of fecal coliform in the dry season, but it's wet, it's warm, and most of that is probably just because it's growing, because we don't see that in the leaf season and the dry season. But if you look at zinc, the whole environment is quite a bit, and here's our little wash up here that we count for stormwater. So this is just comparing dry season, or this is comparing north and south. So compared to south. So we have wash up at the top and the whole environment at the bottom for each one of these parameters. So if you look at the south actually removes less TSS and less phosphorus. And the south has 40% residential compared to the north, which is 64, which is what we find with stormwater. But the south has more copper, zinc, and PCBs. And besides having some more industrial in the south, we also have the port and a lot of heavy traffic. So we get a lot more copper, zinc, and PCBs in the wash up. And if you look in the whole, where we, the north has a lot more fecal coliform, more debris, and more phosphorus, and the south has more copper, zinc, and PCBs. So if we look at the same thing and look at wet season versus dry season, and compared to the wet season, in the wash off, we're getting more copper, zinc, PCBs, phosphorus, and TSS in the wet season. Which can be counterintuitive. How can we be picking up more material when it's all washing off the road? But my theory is that when our roads are wet, pretty much all wet season, so some of that material is just suspended on the road and we just come by and suck it up. In the dry, okay, and now looking at the whole environment, fecal coliform, which is probably temperature related, we pick up way more in the summer. The surprising thing is with copper and zinc, we're picking up the total more copper and more zinc in the dry season. but we pick up less of the wash off, which is kind of counterintuitive. So what it might mean is that sweeping works great in Western Washington during the wet season, and it might also work great in Eastern Washington because we're picking up more of the total copper and the total zinc. So the key metrics that we use to track efficiency, I've got our 2022 costs. If anybody is trying to plan something, our costs are most likely higher than everybody else's, but it might give you a good indication. So if we start off with our costs, it's really $256 an hour for every hour that our sweeper operator is out there. And to convert that into efficiency, it's how much money are we spending per hour that they're actually sweeping. And that's our utilization in 2022. We're at 37%. Our target is 50%. We've been having a terrible time with people. We haven't had enough. We've been using overtime. You can see here we've got 18% overtime is included in this cost. And we just get somebody on night shift because we're sweeping mainly at night. As soon as they get trained up, a job opens up on day shift, they move to day shift. So we have $1.50 an hour differential, but this year we're finally getting some traction. And the thing that SDOT did was start an academy for the laborers to get their commercial driver's license. So they're training them and they're paying for them to get their CDL. So now they can work out of class as a street sweeper operator, get trained up, and then we'll always have people. That's the plan. So the more hours we're sweeping is what we want in shift. The other thing we look at is the dollars per broom mile. So if we sweep faster, then our dollars per broom mile is going to go down. If we sweep slower, it's going to go up. And last year we did about 4.5 miles an hour. We'd like to do 5 miles an hour. But if we were to sweep 7 or 8 miles an hour, then the pickup rate will go down. And so then that means your present value dollars per pound, which is what we really care about, would go up. So it's kind of a balancing. Everything is about balancing, and there's always a challenge. And it's not just the numbers. You've got people and equipment. It just doesn't always do what you want it to do. Equipment is also key. It's balancing. When we started partnering with SDOT, they had some 8000 Schwartz regenerative air sweepers, and you can see it's a high dump. And the intention with the high dump was to be able to put roll-off containers out so they could sweep. They'd be out on the route, dump, keep sweeping instead of having to come back to the shop to dump. And that sounded like a really good idea. But the logistics of just having the roll-off containers, finding a place to put them, getting them out there, then the truck driver has to come back. Logistics were a nightmare. But on top of that, if we're sweeping at night, and our guys need breaks, it's not safe for them. So it's a safety issue. They come back for their breaks. They dump at the yard, they take a break, use the facilities, eat lunch, whatever. So depending on where you're at, for us, it's just safer if they come back. And it doesn't really seem to save that much time. One of the things about these high dumps is there's smaller hopper capacity. And in the leaf season, the weight of the leaves would get so heavy, they wouldn't actually be able to get it up. And then you'd have to get in there and hand shovel it out. So in 2013, we moved to just an end dump. The hopper capacity went from 5.8 to 9.6 cubic yards, which is huge. That means a lot less times coming back to dump. And in 2020, Elgin convinced us to try the Crosswinds. It's a single engine. So theoretically, it's going to have less maintenance because it's only one engine instead of two, and it's also should be quieter. In all of our sweepers, if they're on the California PM10 certified, then that's what we go for. So that's the end of revealing meaningful insights. How are we doing at time? Okay. So the last thing, we want to drive holistic stormwater integration, show value for money, address emerging pollutants, and focus on source control co-benefits. So this is just some charts. On the left, you can see the miles swept and the dollars per mile. And on the right, you can see the tons and the dollars per pound. So even though our costs went crazy here in the last 5 years because our miles went down, we're still dollars per pound have been good. This is comparing street sweeping with regional. So street sweeping up here in brown, regional scales, and the street scale, we just do a lot more. So we need 10 to 20 regional scale facilities to equate to what we're doing now, and that's only counting the 10%. And if it's a street scale, we need like 200 to 400. So maintaining 200 to 400 street scale projects versus street sweeping is just easier. And the cost, street sweeping here, these other ones get really expensive. The other ones, planning, design, permitting, takes a long time to get a project going for us. Our South Park water quality, we've been working on it since 2006 and it's not in the ground yet. Street sweeping plan, get your routes. It takes like a year to buy a sweeper, so that takes some time, but then you're up and ready to go. Back to the one thing I want you to remember, our iceberg. For less than the value of McDonald's breakfast meal, you can get a pound of TSS. It's got all these pollutants attached to it and all these blow off. It's a lot of stuff. So moving on to emerging pollutants, the roads are also a source of microplastics. You know, it's a global concern. Sources on the road include the tires, brakes, the pavement itself, and the marking. And Jarlsberg has shown that street sweeping does remove the microplastics. We did start sampling last year for 6 ppq preliminary results. We've detected in everything. The primary environmental sample, or the whole environment here, the less than 250 here. The trends are kind of, the sample size is really small, so we don't know yet what it's really mean, but you can see the same kind of trends. North is less than south. The primary environmental sample is less than 250. So moving on to co-benefits, healthy waters, as less pollutant washing and blowing off our roadways means less in our waterways. Healthy communities, less pollutants washing and blowing off our roadways means less community exposure. And efficient O&M, less debris on the roadway means less maintenance. So if we measure to produce actionable results, we analyze to reveal meaningful insights that drive holistic stormwater program integration, then we will deliver more environmental and community benefits at lower cost. Street sweeping just needs to be a piece of the puzzle. So I'll challenge all of you. And I hope you would want to do this without the regulation, but it's probably coming. So thank you.